All right, guys and gals, this is going to be the last lesson from Unit 2 of Pre-Algebra. In this lesson, we are going to talk about graphs again. Excuse me. We're going to talk about translation, which is moving around, and we're also going to be talking about reflection, so flipping a graph over an axis. Let's go ahead and dive in. So we're going to start by talking about translations. Okay, so a translation in math, we're talking about taking a graph and we're talking about shifting it up or down or left or right. Okay, so that's what we're talking about here. So let's pop a couple of graphs onto our graph here, and then we'll kind of talk about how this works with pictures and how this works with points as well. So this is the original right here. Okay, so this guy right here is the original, and then it was translated over here. It's probably kind of opposite from pictures. Probably should have done the original light and the final one dark, but that's not what I did. So, and it doesn't really matter, but that's what we're going to do. So this is where we are going to start. We're going to start with this little trapezoid right here. This is our initial figure, which was translated over here. So let's kind of see if we can make sure we understand how it was translated. So in order to do that, what we're going to start out by doing is we're going to start out by labeling the points, the vertices of this shape. Vertices in a shape are the corners, right? Okay, so this first one is at negative 1, 2, 3, 4, 5, negative 5, negative 1. So we went back, we went to the left 5 and down 1. So that's that one. Then this one is at negative 4, negative 1, 2, 3. Right? Negative 4 to the left 4, and then down 3, negative 3. Now it's down 3, remember, from the axis. Nothing has really changed from our Unit 1 discussion of plotting points. All of that is still the same. We're not referencing off of something new or any of those things, right? So then that's this one, and then this one right here, it's real tight in here, so I'm gonna kind of draw an arrow and put it over there. That way it's gonna be kind of easier to see. Excuse me. This one is at negative 3, negative 3. Right? Negative 3. Sorry that I'm a little snarfy today. My allergies are driving me crazy. I mowed yesterday out in the field. I should have worn my respirator. I knew I should have, but I didn't. So there it is. All right, this last point is at negative 1, negative 1, right? Okay. So that's the vertices of this trapezoid, right? So where are the vertices of this one? Well, let's talk about these in terms of movement. So we went up, we took this and we translated it up and to the right, right? That's how we moved it. We went up and then we went to the right. How many did we go up? Now this time we're just going to figure out the difference here. So we went up 1, 2, 3, 4. So we went up 4. And how far did we go to the right? We went to the right. I'm gonna match this point and that point. So we're gonna find the ones that match. See, I did from the top to the top of the trapezoid to the top of the trapezoid. I'm gonna go from this point to this point. Let's figure out how far over we went. Because if we just went from here to here, that's not the complete picture, right? That would be to the right 2, but we didn't go to the right 2 because that would be moving this one in line with that. So it would actually be further over here, right? So let's see how far we did actually go. We went over 1, 2, 3, 4, 5, 6. So we went to the right 6. So let's make some predictions before you could see what's happening. But before we just look at the picture, let's take a look-see and see if we can look at these points and see how they would change and see if it matches the way we would think. So which one of these two parts of the ordered pair are the left and right movement? Well, left to right, you remember, is the x-axis, right? This is the x-axis, this is the y-axis, and points go x, y, right? So this is the x-axis. So if we went to the right 6, then we would add 6 to this. Well, negative 5 plus 6 is how many? Negative 5 plus 6, the signs are different, so we subtract and keep the sign of the bigger one, so it equals 1. So we would expect, and looky here, we would expect the x part of this one to be a 1, right? Look at that, it is over 1. So the y part, so the y, we went up 4, so we're adding 4 to this. So negative 1 plus 4 is what? Well, the signs are different again. We're going to subtract and keep the sign of the bigger one, so it's positive 3. So we should expect it to be at 1, 3. It is, in fact, at 1, 3. So if we didn't have this sort of ghost image of what we're going to, we could figure it out by just adding 4 to this one and adding 6. So if we're translating, we're adding or subtracting. If we're going up, we're going to add. If we go down, we'll subtract. And that's for the y part. If we go left, we're going to subtract. That's for the x part. If we go to the right, we're going to add, right? Just as we move around, that's how we're going to do it. So I'm going to go ahead and label the rest of these points, and then we'll compare and make sure we understand what's going on here. So this point is at this one right here. I'm going to do both of these with arrows. Just we're getting a little jumbled in there. So right here we're at 2, 1. Does that match our expectation? Let's take a look. Negative 4, that's the x part. Negative 4 plus 6 is positive 2. It worked out. Negative 3 plus 4 is positive 1. That also worked out. Yippee skippy. That's really great. Okay, so this one, what is this one? This one right here is at 1, 2, 3, 1. So does that match what our kind of formula, our pattern is? That's matching with this corner here. So negative 3 plus 6 is 3. It works out. Negative 3 plus 4 is 1. That also works out. So see, it always fits the pattern. So this one, we'll just assume it fits the pattern and get it labeled, and we'll move on to a reflection example, and then we'll be done with the unit. Okay, so this one right here, this one is over 1, 2, 3, 4, 5. Up 1, 2, 3, 5, 3. And you can do the math and you'll see that it still works. All right, let's take a look at a reflection example. Oops. All right. So we're going to take this shape and then we're going to reflect it. Now you can do a reflection over any line. At this point in our pre-algebra class, we're always going to be either reflecting, we have a layer to right on here. We're always going to be reflecting over either the x-axis or the y-axis. We're going to flip it over one or the other. So in this example, we're going to look at one that's flipped over the x-axis. So real quick, before we get to the point that's going to be on there, let's see. Let me do these in a totally different color so it's easier to see. They're going to be more distant. But all right, so we've got a little square here. Then we've got a point at 3, 1, 2, 3, 4, 5, 3, 5. We've got a point at 5, 5. And we've got a point at, this is still 3, and we've got 7, so 3, 7. And then we've got a point at 5, 7. So if I wanted to take this and I wanted to reflect it, flip it over the x-axis. So if you kind of picture this x-axis as a place that I'm going to pendulum, what's going to happen is this is going to take and it's going to flip down way down here. So we're going to have the same distance between the x-axis as these first ones. So we would go down 5 instead, right? So down 1, 2, 3, 4, 5, right? We would go down 5 for that. We would go down 7 for here. So what are these points going to be? So if we flip across the, if we flip this across the x-axis, what are our points? Well, for the x part, it's going to stay the same. So the axis that we flipped over, it stayed the same. I'm going to pull up my pre-drawn one right there. There it is. Okay, so if we flip it over, the x part stays the same. Grab this guy. So the x one on all of these is going to be the same, right? X is the same. So this one is 3. This one's 5. This one is 3. And this one is 5. So, oh, oops. I got too excited. Too carried away. This one's 5. So the x part stays the same on a reflection always, right? So for a reflection, the x part always stays the same. What happened to the y part, though? Well, all of the things that were positive now turned into negative, right? And so this would be 3, negative 5. This would be 5, negative 5. 3, negative 7. 5, negative 7. So if we were to take and we were to reflect this the other way and we were to reflect it this way, then all of the y parts would stay the same. It would be this one is real quick to go ahead and pop in here. It would be like that. I kind of drew it a little ugly there because I was doing it in a hurry, but it would look like that. So all of the y parts would stay exactly the same, right? But all of the x parts would flip. So this would be negative 3, 7, negative 5, 7, etc., right? And so that's how translations and reflections work. They're really, really pretty straightforward. A lot of drawing, a lot of those kind of things, but pretty easy peasy. That's it for Unit 2. Thanks for joining us. We'll see you in the next one. Bye-bye.